The present value for perpetuity paying 1 every 2 years with the first payment due immediately is 7.21 at annual effective rate I. Another perpetuity paying R every 3 years with the first payment due at the beginning of year 2 has the same present value at an annual effective rate I plus 0.01. Calculate R. So the first one is a perpetuity due because the first payment happens immediately and it pays every 2 years. So we need the 2-year effective rate. We are given that I is the annual effective rate. Therefore, if we call J as the 2-year effective rate, we have the equation present value equals 1 plus J over J. That's a present value formula for perpetuity due, where each payment is 1. And so from here, we get 7.2 and J equals 1 plus J, and then J comes out to be 0.161. And now the first bit of information has served its purpose. Now we go to the second paragraph. First one helped us calculate J. Actually, we can go on here and find the I as well, because that will be needed for the second bit. So 1 plus I is equal to 1 plus J power 1/2, not 1/3. Because remember, J was the 2-year effective rate. And so it's actually I 1/2 over 1/2. And so the equation of conversion is 1 plus I is equal to 1 plus I 1/2 over 1/2 power 1/2. And I 1/2 over 1/2 is the J, which we found to be 0.161. So we substitute the J here, work out the right-hand side and then subtract 1, get I equals 0.0775. And now for the second perpetuity, the annual rate is I plus 0.01, I plus 0.01. And so we add 0.01 to this I, so we get 0.0875. And that's the annual effective rate for the second perpetuity. Now, they tell us that the second perpetuity starts its payments at the beginning of year 2. Now, the beginning of year 2 is actually time 1, because the beginning of year 1 is time 0. And let me show you from a time diagram. Oh, okay. So in this time diagram, you see the 0 to 1 is year 1. So the beginning of year 1 is time 0. And the year 2 is this one from 1 to 2. The beginning of this year is time 1. So the beginning of year 2 means time 1. So that's when the first payment is happening for the second perpetuity. First payment at the beginning of year 2, which means at time 1. And therefore, if we use the perpetuity due formula for the second one, here the payment is R, and this is happening every 3 years. So let's go back to our problem. And if we let K to be the 3-year effective rate, it can be found by 1 plus the annual effective equals 1 plus K power 1/3. And now normally I write it like 1 plus I is equal to 1 plus whatever this is. But in this case, since I was used for the annual effective rate for the first perpetuity, the second one doesn't have the same annual effective rate, but it was I plus 0.01. So I've directly just written 1 plus the annual effective rate equals 1 plus the 3-year effective rate power 1/3. K is the 3-year effective rate. And so we cube both sides and then subtract 1, get K equals 0.2861. So as we discussed, the second perpetuity has its first payment at time 1. So if we treat it as perpetuity due, then the perpetuity due formula, remember, gives the present value right at the time of the first payment. So it will give its value at time 1. But we want to transfer it to time 0. So because that's what the 7.21 is, when they say that the present value of this perpetuity is the same as the present value of the other one, to say another perpetuity has the same present value. Same present value means same present value as the first one, which was 7.21, and that was the value at time 0. So this means that the value of the second perpetuity is also 7.21 at time 0. But when we use the payment times 1 plus K over K, that gives the value at the time of the first payment, which is time 1. So we want to push it back to time 0. So we multiply it by the 1 over 1 plus the annual effective rate, because from time 1 to time 0, it's 1 year. And we use the 1-year effective rate, which was 0.0875 for the second perpetuity. So 1 over 1 plus the interest rate pushes it back 1 period from time 1 to time 0. And the goal was to calculate R. So we substitute the K and then evaluate all this expression and then divide by it. R comes out to be 1.74. That's choice D.